So, smart cells. Smart cells are about extending the cloud to the edge of the network. Why would you want to do that? Well, there are a set of quite compelling reasons why you want to do that. The first of which is user experience. If you are able to deliver content right from the edge of the cell, the user experience is very considerably better than if you've got to stream it somewhere over a flaky backhaul link, or certainly a backhaul link which is reaching capacity. If we have an air interface which supports, which is what we do have, 3G, 4G and Wi-Fi, and you have a backhaul which is considerably less bandwidth capable than your wireless link, then you do need to do what you can to optimize it so that the end user performance is maximized. In this case, we're talking about caching. And so optimizing backhaul is the second key one, along with end user experience. And the third one is as always, the new application opportunities, which actually there are quite a number that operators are pursuing in this area. So, what do we actually have done? We've teamed up with Intel and put a comms-tuned compute platform into a small cell, and this is basically a core Atom processor, which are immensely powerful, along with some accelerators. So I can take accelerators, for example. And also, optionally, significant amounts of SSD, 40, 80 gigs, if need be, which allows you to do caching. And what this gives you is a smart cell. And just off the edge, it's almost off the edge of my platform. So a platform level, I've got now an intelligent device at the edge. I've got something which is, it's really a blend now. It's extending the internet to the edge. So this is marrying up internet and 3GPP. So there are no standards issues here at all. And what we have done as Ubiquisys is ensure that we can deliver the applications in a secure way and a maintainable way to those cells at the edge. So here's an example. This is actually a demo we have running downstairs. This is caching. So one is proactive caching. So a user, say in a football stadium or in a bar somewhere, downloads the latest losing goal from the England football attempt at winning the World Cup, and then the person, the Italian standing next to them, also wants to do the same things, and that second time, rather than it coming over the backhaul connection, it comes from the local cache. So that's proactive caching. And then we have predictive caching as well, which is, for example, here a lot of people will, on their iPads or even iPhones, they'll have certain things they look at every day, so or throughout the day. So news channels, CNN, BBC, and those things you can actually proactively cache down to the small cells, and these have a huge impact on, as I say, both the end user experience and also the actual how much backhaul we use. So there are many others which other types of applications. Just touching on a few: video, ad servers, so you can store the ads locally. So a lot of the information on, say, on web pages actually doesn't change. So on YouTube web pages, it doesn't change between downloads. So you can actually cache the ads locally or make them locally relevant. Upload proxies as well. So an example would be rather than try and stream a video upload, you can actually store it, proxy it locally, which again would greatly improve the end user experience and also the backhaul use of the backhaul. Other things like McAfee as well. So, quick summary then. Small cells, they come in many flavors. As we've seen, it's not just about outdoor metro cells like lampposts. nor is it just about home devices either. And the femtocell technology is actually extremely appropriate for this in all of the segments. Outdoor metro probably is the one which, as the previous speaker said, one's where there's a balance between whether you use IUH versus IUB. All the other segments, the IUH technology is very appropriate and very scalable to meet the needs. And from a smart cell perspective, end user experience, backhaul, edge cloud opportunities as well, extending out to the edge, which we finding an increasing number of operators are very interested in. So, that's it.
One thing I'm interested in, do you have any concept of extending your edge cloud idea so that it supports consumer-controlled applications, rather like Cisco is currently doing with its Wi-Fi routers, so that you can remotely access a business small cell or a home small cell and run applications on it via the web? It
certainly can. There are no barriers to doing that at all. There are no barriers actually to just have microservers anywhere you want. We put them in the small cells in this particular category because this appears to be the most appropriate, the first one. But whether it's home, enterprise, or just microservers on their own, what we have built is a very scalable back end to ensure that these cells can be provisioned in millions and maintained in millions, applications downloaded in millions of images a day if necessary.
Questions for Will? Yes.
Thanks, Will. Great presentation. Joe Madden here with Mobile Experts. So you mentioned that these indoor metro cells need to be graceful as they hit their capacity with all these guys getting off the subway. Can you expand on that a little bit? I'd like to just get some examples of how you think that graceful handling of additional traffic can be done.
So examples of that particular one of a large number of users hitting at one time, which could be that railway station. It could be if you have cells which automatically turn themselves off and turn themselves on, you need to have a graceful acceptance of users. So in that particular case, we use techniques like access class, where you actually just scan around and you allow certain classes of device on first, and then you build up the number of the different types of devices over time, rather than just try and cope with all devices in one go.
And one more question, yes, on the left.
Okay, this is Hans Becker from Germany. As you can understand, I'm very interested on the LTE of a unit, and I'm interested if the unit will support LTE 800 of Europe.
Does it support 800 megahertz?
Yes.
Yes. Yes, if you can support. We've made it very modular, so the RF part is replaceable. We've made it with multiple bands.
Okay.
So actually, you could have 2 LTE bands there, switchable if you want. It's really up to you. We've had a very significant experience in making different bands. Not surprisingly, UMTS, and it's even going to be even more important on LTE. Fortunately, Silicon has come to our rescue as well, making some very broadband silicon solutions for RF. So it means that it's relatively easy to produce new bands.
Okay, thank you.